A significant outbreak of severe weather is expected across parts of the Midwest all the way down to the Ozarks later today, March 31st, 2023. And as of the latest update, the Storm Prediction Center does have 2 moderate risk areas. This includes parts of Iowa, Illinois, Missouri, Arkansas, Tennessee. These areas could see significant severe weather, ranging from significant tornadoes to very large hail to destructive straight-line winds. Now, we're doing this video in a little bit different of a format than what you're used to, and in this way I can record a fuller image, I can record longer, so you're probably not getting as rushed of a view as what you are probably used to. So hopefully this increases the quality, hopefully it works out better. Let me know what you think about it. So we're going to start off seeing what comes together for this in this forecast discussion by looking at the upper level observations from earlier this evening. So this is 00Z on the 31st. And that is about 8 p.m. Eastern Daylight Time from yesterday. And the main player that we have here, the main disturbance, is right in here. You can see that positive tilt to this trough here. And right in here, that tight temperature gradient represents where the main piece of energy is located, where the winds are maximized, and we have a very strong mid-level vorticity disturbance. And that's modeled very well right here over Southern California. You can plainly see that disturbance down there. That's going to be moving off to the east and ejecting into the central U.S., eventually the Midwest, providing the energy needed to really get this outbreak going. So we're going to play this forward. This is 500 millibar vertical vorticity, relative vorticity. And you see that eject into the plains here by parts of the late morning hours even. And you get the idea that there's a disturbance up here in the northern plains already, something going on right here, but this beast of a disturbance down here, this intense vorticity disturbance, it gets slung around this into parts in the Midwest, kind of a slingshot effect going into the Midwest with very dynamic presentation here. Right here, as you can see, it forces this wave into a negative tilt. We get very strong dynamics, we get amplifying mid-level flow. Now you can plainly see that wave is negatively tilted with those strong dynamics. And we can also look at that from how it affects the wind. 500 millibar wind and geopotential height contours. As this disturbance moves out into the central plains, look at this. The mid-level jet amplifies very quickly and becomes very strong over parts of the Midwest, the southern plains. Right through here, we've got really strong flow just blasting into and over parts of the open warm sector. And in the exit region, the left exit region of that, you can see the flow is characterized by very strong defluence, where these height contours are spraying apart, and divergence, where we're getting air lifting by direct circulation. So, left exit region divergence is leading to surface pressure falls. That's what you get as that air starts to rise. So, here's the surface low. Initially, by the Weather Prediction Center, it is modeled over parts of Nebraska. We can see that in the morning. This also shows where frontal boundaries are located, so here's the low pressure, and here's a cold front, maybe taking on dry line characteristics at some point, but eventually will become a cold front, certainly as it spreads eastward and provides a forcing for some more storms. But a main thing to keep in mind here is what's happening to the surface low. By 00Z, we might be down to minimum central pressure of 987 millibars. Really strong, really rapid pressure falls, and that's taking place as it moves here into northern Iowa. We're going to be seeing a very strong cold front move eastward, generating more storms, and because of the really strong pressure falls generated by this, a good mass response. We're getting that pressure, the pressure falls are pulling in the air, the warm, moist air from the south, all the way into the Midwest. And we can see here surface dew points. It's already moist down in Oklahoma, Texas, Arkansas. We've got moisture down here, but that's streaming northward into parts of Iowa, Missouri, Illinois, as we head further into the day. So we play this forward, we're looking into the afternoon here, moisture increasing, you can see those values getting a little bit deeper, and here by 21Z, a good corridor of moisture is present across parts of Iowa, Illinois, Missouri, the Ozarks. Right in through here, we even get some 60 dew points into parts of Indiana as well, so some moisture being maintained into my territory. But yeah, we're dealing with maximized moisture right in through about here even, where we've got dew points in the low to mid 60s. So that's providing the moisture that we need for the instability. But another thing to pay attention to here, this is showing 10-meter winds. So in response to the pressure falls, especially in the evening, we might be getting a little more backing of the surface wind and increasing the wind shear profile in the low levels right in through here. So that could be yielding more supercell potential, a better low-level wind profile for those organized storms. Keep that in mind if you are in eastern Iowa, central to northern Illinois, and northwest or northeastern parts of Missouri. So playing that forward as well, I do want to play this out a little bit to where we do keep that into Indiana. That moist axis by 03Z is spread right over my area, where we do maintain modest buoyancy and pretty good moisture. Now, the moisture is one aspect of developing the instability we need for thunderstorms, but another aspect is how the thermal profile is changing with height. And we can see this by mid-level lapse rates. That's how quickly the temperature is changing with height in the mid-levels of the atmosphere. Now, as we start this off, we're already seeing in the morning really steep mid-level lapse rates over parts of Iowa. And if we take a forecast sounding from there, we can see why. Evidence of an EML. You can see where that hydrolapse is and that temperature inversion. That's evidence of an EML right there. Typically, what you want to look for to find one. But another thing I do want to point out here is right in here, the mid-level temperatures are quite cold, and that's because the mid-level lapse rates are being steepened by two things, actually. Firstly, the influences of the EML, but secondly, as that system begins to tilt negatively, tilt like this, it's spreading cold upper-level temperatures over parts of the Midwest. And as we get that, that means the influences of falling temperatures aloft, so cold temperatures aloft, warm at the surface, and the EML influences, those are going to combine to steepen the lapse rates. So through the afternoon, this is going to be 19Z, through the afternoon, say about 22Z for example, storms are really raging across the area by now. They should be anyway, and we've got some pretty steep lapse rates. Probably not quite to Indiana. They might make it partly to Indiana, but eastern Iowa, southeast Missouri, northeast Arkansas, parts of Indiana, and central to northern Illinois in particular, we've got steep lapse rates, temperatures falling rapidly with height, increasing the instability, especially across parts of Iowa and Illinois. Also, parts of northeast Missouri as well, if we do get the storms there. So when we combine these things together, we have a situation where we might have appreciable instability to work with. We have appreciable instability to work with, as you can see right here. I have accidentally opened up this window in a new tab, so you know, we're dealing with a longer video here. You might see a couple errors that I normally don't do in the 10-minute version. But we're going to focus on what the instability does here so we can see how the thermodynamic environment evolves, because this is very important for how thunderstorms are going to develop in the day. Instability is already developing during the morning hours across parts of Illinois, so right over in here you might get some storms going early, but the main thing to keep in mind is what happens in this main corridor of instability. 22Z, for example, here we go, a corridor of moderate to even large mixed layer CAPE. Mixed layer CAPE is one of the calculations that we look through for CAPE, where we take an average of low-level conditions and then calculate CAPE from there. It's a little more accurate most of the time because surface-based CAPE only takes surface-based parcels into account, so only surface and dew point, surface dew point and temperature conditions. But this is a mixed layer, so we're dealing with probably a more accurate representation of the lower atmosphere and how a parcel is going to behave as we lift it. So the important thing to derive from this is that we have moderate instability across parts of Missouri, Illinois, Iowa, the same places we were talking about. Also some instability further south into Texas and Arkansas, parts of the Ozark area, southeast Missouri. But from my thinking here, we will have better moisture, but probably not quite as steep of lapse rates, probably not as strong of influences from the cold air aloft. So instability might end up actually being maximized across the northern area, Iowa, Illinois. So you've got pretty good cape going on there, sufficient for really strong updrafts. And we play that forward again, as I mentioned earlier, with that moist axis moving into Indiana. Modest buoyancy does persist across this region into the overnight hours. This is 10 p.m. Eastern, 9 p.m. Central, so the sun is set, it's getting dark, and you've still got enough energy to maintain those thunderstorms in this area. So that's kind of a thermodynamic view of things, but another aspect we need to look at is the wind shear profile. How the wind shear is changing with height. Wind shear being how wind changes with height from a directional and a speed perspective. And we've got both. Because as that mid-level jet comes into the region, we were looking at that just a little bit ago, you can see how that's going to rapidly amplify the wind profile in the mid-levels and increase the deep layer wind shear. So by 21Z here, we've got a rough estimate right through here. Our 0 to 6 kilometer bulk shear is on the order of 55 to 70 knots, and in some locations it's higher, 75 to 80 knots. Now, normally you can get organized storms at 35 to 40 knots of 0 to 6 bulk shear. We're dealing with values much higher than that right here. And note that the vectors are perpendicular. Actually, I should use an arrow here. Perpendicular to any of the initiating boundaries that we have, such as that dry line or potentially prefrontal lifting from confluence bands or perhaps a lead shortwave disturbance. The point of it all is that regardless of the lifting mechanism, the perpendicular wind shear vectors, that facilitates supercellular development. It makes it more probable. And that certainly seems to be the case here. Now, the low-level perspective is also very important because, again, as those pressure falls persist, that increases the pressure gradient response, pressure gradient force strengthens, and we get a really strong low-level jet. Now, you can see in the morning things are already going pretty strong across parts of the Ozarks, spreading into parts of Illinois. Pretty good low-level jet going on right now. But as we play this forward here, things really start to amplify in the afternoon. 00Z, we've got really amplified low-level wind fields all the way throughout this area here. 850 millibar winds are really going to rip out of the southeast, or the southwest even. We're looking at values of 60 to 70 knots. Once you head into Indiana, it might even go into the 70 to 80 knot range. That is really strong low-level wind shear, and that indicates, and I'm going to play this forward here, that indicates where we're having these hodograph structures being really enlarged, really strengthened even. And we can look here at the 0 to 1 SRH. 0 to 1 kilometer storm relative velocity is essentially the accumulated vorticity over a layer of the atmosphere with respect to the storm motion, and it gives us an idea of the propensity for spin in the atmosphere, essentially. And 0 to 1 kilometer is very important when it comes to mesocyclones and tornadoes. So 0 to 1 SRH, the propensity for storms to acquire rotation. You can see it's already getting high across parts of Missouri, even Arkansas, central Illinois, southeastern Iowa as well. Now this is from the NAM, so we have these intervals going in about 3 hours, so we're not seeing as fine of details with the rapid refresh on the spatial extent. But we do get the idea that we've got really strong SRH values. Typically, you only need to see 150 or so to get some tornadoes out of this. We're dealing with values here of 3 to 400 meters squared per second squared, even potentially higher. By the evening, we've got this spread up all the way into northern parts of Illinois, southeastern Missouri, spreading into Indiana as well. You've got really large values of storm relative velocity, and that continues into the evening from there even. Values over my area could be over 450 meters squared per second squared, maintaining a tornado risk as we head into the evening and regardless of the storm mode. But it does indicate, certainly in supercells, we're going to be dealing with a lot of rotation potential. SRH not necessarily applying so much to linear modes, but the low-level shear is indicated absolutely. Now, of all these parameters, of all these things we've looked at, what might that look like in a vertical plot of the atmosphere? A vertical plot is represented here by a forecast sounding, which shows the distribution of various meteorological parameters in the vertical. Many useful tools to work with, including the instability over here, the SQT map. You can see right down here, that's our instability profile. Also, this is a hodograph. You're probably familiar with these already, but if you're not, that's what they're called, and they're going to give us an idea of what the atmosphere might look like going ahead. So first of all, we do note the hodograph, very, very curved, very elongated, and also the deep layer shear vectors, if we start out from the 0 marker right here, and go to 6 kilometer, those are really strong. That is a really strong vector out of the west-southwest. So again, crossing the initiating boundary and facilitating supercell development, especially when combined with that low-level curving and that speed shear. Speed shear is really strong, and we might even amplify this profile again if we get stronger backed surface wind vectors, which that's very possible with the pressure falls that we're dealing with here. And if we look over here to the instability aspect of things, again, you've got some pretty good cape, sizable cape all the way with equilibrium levels right here. You can see the equilibrium level. That's where the cape is not calculated anymore. That's our cloud tops, essentially. That's where your anvil is going to be spreading out. We can see that is very high in the atmosphere, almost 12 kilometers above ground. So that instability is very apparent right through here. We've got that positive area, that's what that's referred to, that's where the cape is. But also we've got a moist layer down below because, again, a lot of moisture streaming in. So that moist layer is characterized by high relative humidity, probably lower LCLs than what is depicted here. Also probably going to be getting areas of larger 3 cape. I know it says 0 right here, but we're probably going to be getting larger values of that in certain parts of East Iowa, North Illinois, northeastern Missouri. So don't discredit that based on the sounding alone. This is just one sounding. But you get the idea. Lots of wind shear and a moderate instability profile to work with. The wind shear is indicated further down here where we've got very strong 0 to 6 vector is 68, or magnitude I should say, is 68 knots. Surface to 8 kilometer bulk shear is 82 knots. And according to a 2006 study, you can get long-lived supercells above 50 knots of this, so that's well supportive of long-lived organized mesocyclones, especially once you consider this. The SRH 0 to 1 is over 400 meters squared per second squared. That is pretty tremendous. And when you put all that together, the parameter space is quite high. I mean, you look down here, we've got elevated values of supercell composite parameter, significant tornado parameter, and significant hail parameter. All of those suggesting the potential for significant severe weather, but especially the tornado risk here. That's concerning. Values of 3 to 4. So that is a pretty interesting environment here. I do want to take a sounding too once we get into central Indiana, and actually I'm gonna go back a bit. Yeah, so we're gonna put this in southern Indiana. This is gonna be roughly north of Bloomington. And that's not what I wanted actually. So okay, we're gonna take this. This is Indianapolis. This is gonna be 03Z Indianapolis. Because I am expressing some concern about this. I think the tornado and wind threat will probably be expanded further towards central Indiana as we get some of these later SPC outlooks, because look at this. You thought that was a curved and elongated hodograph before. Well, look at that. This is my neck of the woods. This is central Indiana by 11 p.m. Eastern Time. We're dealing with really elongated hodographs, really strong speed shear, tremendous actually. Look at this speed shear down here in the vertical wind barbs. That is rapidly amplifying with height, given that low-level jet. The curvature's there, so we're going to be persisting that low-level wind environment. Instability, it is going to be there. It is going to improve in the evening as we get that moisture and that moist axis move in. And you do eventually even get influences that look like that EML right through here. So maybe some EML influences do persist. Um, we'll have to see if it gets diffuse, if it's still well defined. That's gonna also how much moisture return we get. That's really going to determine how our thermodynamic environment evolves. Keep in mind this is the NAM 12 kilometer, so whatever bias is inherent with it, that would be something to take into consideration. But the thing I'm concerned about is right down here, 0 to 1 SRH, 528 meters squared per second squared. That is very large. And 0 to 1 kilometer bulk shear. Look at this. This is the bulk shear in the lowest kilometer of the atmosphere, 55 knots. Adding to the deep layer shear that's over 70 to 80 knots. So the idea here is that once we move into Indiana, we're still dealing with really strong wind shear vectors, really strong wind shear magnitudes, and that's reflected down into Kentucky as well. We take a sounding from western Kentucky. Look at this. That wind profile is really curved, really elongated. And that curvature could, and also over here I do want to mention this, EML is still present. But that vertical wind profile, that could support supercell structures being maintained into Kentucky, western Indiana, central Indiana even. That's part of why I think this risk is going to be, that moderate or the enhanced risk could be extended into central parts of Indiana as we get some of these later outlooks. Another thing I want to point out, and this is particularly for people downstream of these storms and for storm chasers going to be out there today, you know who you are. Look at this. The storm motion vector is really, really strong here, really elongated for a right-moving supercell. This estimates that if you get a right-moving supercell in the environment of East Iowa, North Central Illinois perhaps, we could be dealing with storm motions of up to about 60 knots. So these storms are going to be moving very quickly. For storm chasers, it's going to be hard to keep up with. For people downstream of these storms, regarding how warnings are going to go, you're going to get the warning, and then the storm's going to come in very, very quickly, like 60 miles per hour, even perhaps 70 in some of these. So moving really quickly, that means it's very important that when you get a warning, you need to enact your sheltering actions as soon as the warning is issued. It's going to come in quickly. Don't wait to see or hear what's happening. Just take shelter immediately. That's going to be your best bet for getting out of this unscathed with minimal threat to your life. So we've looked at all the environmental conditions. Now we're going to look at the HRRR 06Z run, simulated reflectivity. Now this is one possible solution of what might happen today based on from a radar perspective, but it's not necessarily what will happen. So don't take this as being 100% accurate. This is just one idea of what might happen. Now, in the morning hours, 14Z here, we've got some showers and storms popped up over Indiana, Michigan. These are probably going to be elevated storms that are not too strong, maybe some small hail embedded within them. Not a whole lot going on over here in Illinois, Iowa, and Missouri. That means the storms that are going over here, or the environment over here, we're not having a whole lot of storms develop that would otherwise overturn the atmosphere, wipe out the lapse rates. So that is being preserved and getting ready for the main show. 16Z, still basically the same, although we do have some activity in West Missouri, northern Arkansas, trying to get consolidated a little bit. Now here's where things we start to get that signal for things starting to go off. Northern Missouri and parts of southern Missouri, northern Arkansas, not quite as strong down south, but up north, that is supercellular in appearance. Now play that forward too. It's getting larger. We're getting more of these storms. These supercells are starting to grow upscale. By 18Z, 19Z, we've got even more of them. So all the way through here, we've got these supercells starting to mature and organize. These could be the ones that are starting to become tornadic. Further south too, into northern Arkansas and southern central Missouri, these storms are organized as well, and we do have some tornado risk. Obviously with that moderate risk, we do have a pretty substantial tornado threat with some of these. Although, if we're comparing the two areas, personally, it seems like this area here is going to be exposed to more dynamics, more influences of the surface low, better backing of the low-level wind profile, or of the surface wind, I should say. So this area seems to be more dynamic and seems to have a higher probability of yielding a tornado outbreak with really organized supercells. Down here, we are going to be seeing some organized storms, including organized supercell risk, but we do have clustering concerns, so that might diminish it a bit. And I think that overall, it might not end up being as significant as what we see further to the north. However, that's not to diminish the risk. You do still have a strong tornado threat, as we're going to be looking at here in the coming frames. Now, you've seen this organize up in northwestern Illinois, eastern Iowa, but now look at this. We've got these classic hooked supercell structures going on right through here with strong updraft helicity tracks indicating organized, strong, long-lived mesocyclones. So once you are in around the Davenport area, east and south of there, you're starting to deal with these organized, discrete supercells that are probably going to be tornadic. And at this point, given the environment that we're dealing with and that they are going to be evolving into, as we play this forward too, look at these. We're dealing with a situation where we've got significant severe weather that is looking pretty likely. Also, back toward the surface low triple point frontal lifting here, we've got additional storms that are developing. So maybe multiple rounds of supercells taking place across Iowa, northern Illinois, northwest Missouri, all capable of significant hazards, including these over here. These are concerning. That is a concerning look as we move through northern, central, northern parts of Illinois. These storms could be capable of very large hail, perhaps above 2 to 3 inches in diameter, and significant tornadoes, perhaps intense tornadoes, that's EF3 plus, headed into these areas. And they're going to be moving very quickly, so destructive tornadoes moving quickly from organized storms, that is a concerning aspect. And we've got more supercells down the line down here once you get into southeast Missouri, northeastern Arkansas. Given the factors I mentioned before, perhaps it doesn't work out as well for tornadoes down here. These aren't as prolific for tornadoes, but still you have a risk for tornadoes and potentially a corridor of significant tornado risk, and I'm going to mark that out right in about through here. Conditionally, if you get some supercells down here during the afternoon hours and evening, you might end up with a threat for significant tornadoes. That's going to be EF2 plus, capable of considerable damage. So we play this forward again. 22Z, things are still roaring across northern parts of Illinois. We're getting close to the Chicago suburbs now with these long-lived tornadic supercells going right in through here. Maybe even down to the Champaign, Illinois area. Intense organized supercells producing tornadoes, very large hail, and increasingly so as we head eastward, significant damaging wind risk. Now, remember that low-level jet's going to be ripping at 70 knots or so as we head eastward. As you get into parts of northern, eastern Illinois, western Indiana, maybe central Indiana too, especially in the more organized portions of this line, you might be seeing some significant damaging winds. I would say gusts of 70 to 80 miles per hour are entirely possible. Now play that forward too, and this might be manifest a little more consistently once we get that frontal lifting taking place right over here. So heading through the evening, that's going to be an increasing risk. And again, northern Illinois, you've been battered by storms at this point, but you've got more coming in. And these are supercellular again, because remember, those wind shear vectors are crossing about like this. So that increases your potential for supercell thunderstorms. And as we play this forward into western parts of Indiana, now we do want to note too, again, that southern risk area, as we head into the evening hours, the overnight, we do still maintain supercells. We do still maintain a tornado risk across parts of northeast Arkansas, northern Mississippi, western Tennessee. Tornadoes are quite possible. But thankfully, by this time, most of southeast Missouri, you're in the clear. Also, northeast Arkansas, you should be good. Uh, the main target area up here should be clear of severe storms. Now we're looking off to the east of there. As we move this line of storms into western Indiana, also western Kentucky, we're probably still going to have embedded supercellular characteristics in addition to other dynamic features. Those include mesovortices, line-up wave patterns, rear inflow jets. Those features enhance the potential for significant damaging winds and also maintain that tornado risk as we head eastward. That's why I do think this tornado risk is going to be probably extended a bit eastward into central Indiana, because you've got, by 11 p.m. Eastern Time, a pretty powerful line of storms with widespread damaging wind risk and perhaps embedded tornadoes moving through parts of central Indiana down to western Kentucky. Now, the good news comes as we head beyond here. Midnight Eastern Time starts to lose definition a bit. 1 a.m. Eastern Time, 2 a.m. Eastern Time. By now, all of our storms have pretty much merged, grown upscale, and they're starting to lose their intensity because they have become removed, especially in northern areas, from that instability axis. Down south, you've got more moisture, so you might keep this going a little bit longer into the night. Down into central Tennessee, northern Alabama perhaps. But Ohio, your risk is going to be diminishing quickly as it moves eastward. Kentucky, eastern parts of Kentucky, a lesser risk than places further to your west. And pretty much that's what we have to cover here. This is what we're looking at now based on the current guidance, based on the current outlooks. A moderate risk is right in through here. But I do want to point out here, and this is just kind of based on my interpretation of things, I could see that moderate risk getting extended a little bit eastward and maybe southward. So into these areas here, be on the lookout. That moderate risk might get extended. You might have a significant tornado threat. Now this area down to the south, it's a little more of a question mark, I suppose you might say. But you still have a conditional threat for significant tornadoes. Don't let your guard down. Memphis, Tennessee, Jonesboro, Arkansas, Little Rock, Arkansas, far southeastern Missouri even. Keep in mind, you do still have a readily evident tornado risk, and if you get a discrete supercell in that environment, it might become a significant tornado threat. Now, looking at the damaging wind potential, I'm going to mark this in a different color to kind of distinguish between them. You're really probably going to start to... Actually, that might not be too visible. And we're going to go with this. You might start to ramp things up a bit about in this area as you start to get more upscale growth. And those storms might try to grow upscale too into western Kentucky, but especially to continuing into central parts of Indiana. You've got damaging wind risk. Some of these gusts are going to be really strong, maybe over 75 miles an hour. So keep that in mind too. Straight line winds are going to be a hazard. And lastly, we're looking at a hail risk, because I think the hail risk has kind of been overlooked for today. It's looking pretty significant once you get the initial storm modes right in through here, especially with those organized supercells. You could be having hail that's 2 to 3 inches in diameter, maybe even larger. So keep that in mind too. Very large hail, significant tornadoes that are fast moving and perhaps long lived, and significant damaging winds. And that's kind of the story of what we're dealing with today, and that's kind of an event summary, or not an event summary, but a forecast discussion of what we could be dealing with today. Stay safe, have your NOAA weather radios charged and working. Have a phone app too to keep up with warnings that are issued. Your phone app should go off too if you get put in a tornado warning or a significantly severe thunderstorm warning. So that's a good thing to keep in mind. If you are placed under a tornado warning or a significant severe thunderstorm warning, while I'm talking about this, I'm going to just kind of let this play. If you get placed under a warning, keep in mind you want to take shelter immediately. You don't want to wait to see or hear the storms, because they're going to be moving in really quickly. Really quickly, like this. This is animated too quickly. Storms moving very fast. Going to be, especially with eastward extent, harder to see because you're going to be headed into night and you're going to be dealing with more rain wrapping. So, Indiana, Illinois, eastern Illinois, be aware of that. If you're placed under a tornado warning, be sure to seek shelter on the lowest floor of a sturdy building away from windows, with the most walls between you and the outside as possible. That's going to be your best chance of coming out of this unscathed if the worst is to happen. They're going to be fast moving again, as I mentioned, so as soon as a warning issued, take shelter. Get on a mobile homes. Don't want to be in a mobile home. Don't want to be in a vehicle. Don't want to be in a large span roof building. If you are in one of those, like a mall, a shopping center, seek shelter in a designated tornado sheltering area or a restroom, an interior restroom where they don't have windows that would provide that blowing glass and wind entry point hazard. So this has kind of been an event, a forecast discussion for this. Hopefully you found it involved, detailed, and hopefully relieving, because I know there's going to be a lot of nervous people ahead of this, and I sympathize with that, ahead of this risk. But the best thing you can do is to keep informed. So pay attention to local weather resources. Look up weather streams on YouTube. I know David Schlotthauer is going to be streaming for a little bit. Check him out. Going to be providing some live updates on the radar evolution of these storms, and official resources going to keep you up on the watches and warnings. So everyone stay safe and stay weather aware as we head into this potential severe weather outbreak.